Good morning, Vanakkam. Today we are going to learn about multiplexer. Multiplexer is also known as data selector as it selects one data input from many data inputs. In simple words, many to one. To design a multiplexer, we need to follow the 5 steps. First step is the definition. Second, the block diagram. Third step is framing the truth table from the concept of block diagram. Fourth is writing Boolean expression from the truth table. The final step is drawing the logic diagram. First, we see the definition. A multiplexer is a combinational digital circuit which selects one input amongst many inputs and pass it to the output side based on the selection inputs. The second step is drawing the block diagram based on the problem statement in the definition. This block is trapezoid in shape. We name it as MUX. There are n number of inputs. So we name them as I0, I1, I2, I3 and finally In-1. Hence there are n inputs, single output which is named as Y. There are m number of selection lines. We name them as S0 to Sm. The relationship between selection lines and the input lines is given as n equal to 2 power m, where m is the number of control lines or the selection lines and n is the number of input lines. We would like to now design a 4x1 MUX. Hence the block diagram consists of two selection lines S1 and S0 and 2 to the power 2. That means 4 input lines, namely I0, I1, I2 and I3 are available. Based on the block diagram, we frame the truth table. It consists of 6 input columns. Column number 1, 2, 3, 4, 5, 6 and finally one output column. We start naming the inputs as S1, S0 for the selection lines. Then for the input lines, they are I3, I2, I1, I0 and the output as Y. Then we place the selection input combinations as 0, 0, 0, 1, 1, 0, 1, 1. Since S1 and S0 are 0, 0, only I0 will be selected. The remaining inputs are considered as don't care. Hence the output is I0 only. When S1 is 0 and S0 is 1, the I1 input will be selected. Hence the output is connected to I1 line and the output may have either 1 or 0 value depending on the input value available at this I1 line. When S1 is equal to 1 and S0 is equal to 0, this I2 input line will be connected to the output side and this output value may be either 0 or 1 depending on the input available at this input line. Similarly, when S1 is equal to 1 and S0 is equal to 1, this I3 line will be connected to the output side. Now we are going to write the Boolean expression from the truth table. So we need this truth table. Now we are going to write the output. Y is equal to first we take this input combination for this I naught. So this is input combination is this one, right? S1 is equal to 0, so it can be written as S1 dash. Then S0 is 0, so S0 dash. Then I naught is written as such. So we get this as S1 dash, S0 dash, I naught for the first input combination of this I naught output. Then the second is Y is I1 for this input combination. For this we can write it like S1 dash, S0, and then this I1. Then we go for the third combination, for which we get S1 as 1, S0 as 0, so S0 dash, then I2. Then we go for the last combination, that is S1 is 1, S0 is 1, I3 is there, so it is S1, S0, I3. So we got the Boolean expression finally as Y equal to S1 dash, S0 dash, I0 plus S1 dash, S0, I1 plus S1, S0 dash, I2 plus S1, S0, I3. Now we are going to draw the logic diagram. This is the final step, isn't it? For that we have to draw all the input lines, that is the selection lines, and the direct data lines or the input lines. So it is S1, S0, I3, I2, I1, I0. So we are going to draw the logic diagram for this first term. For the first combination is S1 dash, right? So we are having the inverter. Then S0 dash, so the connection is taken from this S0 and then inverter is connected. Then the third is this I0. So these three variables are connected with the help of this AND gate. Okay, so it is ANDed, so connect them using the AND gate. Then go for the second combination. Second combination is S1 dash, so it must be having the inverter here. Then the S0, so directly taken from S0. Then I1, so it must be directly taken out of this I1 line. Then they are ANDed together and given to this AND gate. Then the third combination is S1, S0 dash. So we take the connection from here. S1 is direct connection. Then out of this S0, it is inverted because it is, since it is S0 dash. Then the third is taken out of this I2. Then they are ANDed together. So we got the third combination. Then the final combination is S1, S0, I3. So we take the connection from S1, S0, and then I3. Then they are ANDed together here, right? So we got all these terms separately. Then they are connected using this plus sign, isn't it? In between these four combinations, we have the plus. Plus is nothing but the OR operator. So they are ORed. They are connected using this OR gate. And finally we got the output here. So that output expression can be written like this, which is the Boolean expression already we got, right? So in this way we have constructed the 4x1 MUX. Thank you.